Welcome everyone, this is problem number 10 of the chaotic review. We want to classify the discontinuities of g of x over f of x. So let's go ahead and maybe write this thing down. G of x again is x squared minus 1, and f of x is going to be equal to x squared plus 2x minus 3. So there were three types of discontinuities that we need to remember about. There are removable, there are jump, and there are infinite. So in order to first of all kind of identify where we have discontinuities, that's where we're going to have the denominators equal to 0. So I'm going to take the denominator and figure out when it's equal to 0. This will tell me where I have discontinuities. So x squared plus 2x minus 3, if I set that equal to 0, I can factor this. So I'm going to have x plus 3 and x minus 1. So I'm going to have at x equals negative 3 and at x equals 1, there are discontinuities. All right, in order to classify these discontinuities, right, we need to see what kind of the numerator is up to, right? So for instance, if I was to plug in negative 3, so if I plug in negative 3 back into my original function here, right? So I would have negative 3 squared, that's going to be 9, minus 1, that's going to be 8. And in the denominator, well, this is one of the places where the denominator is equal to 0. So if I plug in negative 3 here, let's see, I'm going to get 9 minus 6 minus 3, so that's going to be 0. So I'm going to have an 8 over 0 situation, right? So this is a non-zero. Sometimes in class, right, I refer to this as just n, some non-zero divided by 0. And when you have a non-zero divided by 0, this is an indicator that we have an infinite discontinuity. So I'm going to say, so x equals negative 3 is an infinite discontinuity. All right. How about when x is equal to 1? So when x is equal to 1, again, if I was to plug that into the numerator here, I'd have 1 squared minus 1. That's going to be 0. And let's see, if I was to plug it in the denominator, I would also get 0, again, because 1 is one of these places where the denominator is equal to 0. Double check, right? 1 plus 2 minus 3, that's indeed equal to 0. So I have a 0 over 0 situation. So most likely, we have x equals 1 is a removable discontinuity. But let's go ahead and double check, right? So the act of removing a removable discontinuity is when I simplify this down. So if I was to go ahead and take this really quick, and if I was to factor, right, in the numerator, I would have x minus 1 times x plus 1, right, because this is a difference of squares. And in the denominator, well, I already factored that down here, right? It's x plus 3 and x minus 1. And we can see now that the x minus 1s perfectly cancel out. And now if I was to plug in 1, right, I would have 2 on top and 4 on bottom, right? So I've effectively removed this discontinuity, right? This makes sense. So this is saying that again, so x equals 1 is a removable discontinuity. And again, this most of the time happens at 0 over 0. So again, we classified the discontinuities. We identified which values are discontinuities at negative 3 and at 1, and then we classified them. Negative 3 is an infinite discontinuity, 1 is a removable discontinuity. All right, that's it for problem number 10. I'll see you guys next time.